So in this last video, we're going to take a look at the midpoint formula and the distance formula. And these actually might be formulas you've done in like an algebra class before. And these formulas are talking about midpoints and distance on a coordinate plane. So when we're dealing with problems like this, we'll be looking at an XY coordinate plane. With these, it's just applying formulas. The midpoint formula, I'm just going to help you find the point in the middle. So since we're talking about coordinate points, remember when you guys did like slope and stuff and your equation for slope was y2 minus y1 over x2 minus x1? Similar concept here where we're going to have to deal with 2 points labeled x1, y1 and x2, y2. So I'm going to write that down in the middle here just so you know what we're talking about. So this is if we have an x1 and a y1 and an x2 with a y2. So those are going to be the points I'm referring to. So for our midpoint formula, what we do is we take our x's, so x1, and we add x2 to it. So add your x's and divide by 2. The reason we do that is midpoint, right? That's the middle, and that's like the average. If you're finding the average of two numbers, you add them up and divide by 2. So you're going to add up your x coordinates, divide by 2, and then add up your y coordinates and divide by 2. So x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Then our distance formula is d equals, and then you have a big square root sign. Don't forget about that part, and we're going to put the rest under it. And what you do is you subtract your x's, so you do x1 minus x2 or x2 minus x1. The order doesn't matter as long as you keep it consistent. So I'm going to do x1 minus x2 quantity squared, so put it in parentheses, plus y1 minus y2 quantity squared, and then you have the square root sign over the whole thing. So subtract your x's, square it, plus subtract your y's, square it, and then square root the whole thing. So if you don't have a calculator out, I would make sure you get one out for that. Don't plug the whole thing in all at once, but you might want to plug in some in-between steps. You never want to plug everything into your calculator at once with a distance formula problem, because if you plug something in incorrectly, you could get a negative number, and then your calculator is just going to yell at you. It's going to tell you like invalid or whatever it says. So just make sure you're being careful with that. So for example 4, we're going to look at this grid on the right here. We have point S is 1, 1, point T is 5, negative 3, and point R is negative 3, negative 2. It says use the coordinate grid to the right. So ST, weird, it's not even posing a question. This is when you got to know your labeling. When you see ST with no bar above it, that means find the measure of ST or the length. That means the same thing. Measure, length, value, it's all the same. So this means find the distance or the length. Same idea in this situation, because the distance between S and T is the same thing as the measure of ST. So first thing that I really like to do is I like to write down my coordinate points so that I'm not going back and forth between my picture. So point S is 1, 1, and point T is 5, negative 3. The other reason I like to do that is because now I can label my x1s, my y1s, my x2s, and my y2s. Doesn't matter which one you want to do is which. I'm going to do S as x1, y1, and then T is x2, y2. And now I'm going to plug in my information. So ST equals the square root of, and then I'm going to subtract my x's. So that's 1 and 5. So do 1 minus 5 quantity squared plus, and now subtract your y's. 1 minus a negative 3 quantity squared. Now we're going to simplify in our parentheses. Right, use your order of operations, parentheses come first. 1 minus 5 is negative 4, and you're going to keep your parentheses. Those are still important. Plus, and they're important because of the negative. A negative and a negative is going to make a positive. So 1 plus 3 is going to be positive 4 squared again. And now keep simplifying. Negative 4 squared is 16. So square root of 16 plus 4 squared, which is 16. 16 plus 16 is 32. So your answer is the square root of 32. However, that's actually not a completely simplified answer. Back in Algebra 1, you guys learned how to reduce radicals. This radical can be reduced. If you need help reducing radicals, I'm going to add in a video at the bottom of your note page just in case you need a little refresher. There's a lot of different strategies, so let me know if you need some help. If you don't like I'm just going to find a YouTube video on it. So for 32, what I like to do, you can either make a tree, like a factor tree, or just think of the biggest perfect square that goes into 32. Your perfect squares are 4, 9, 16, 25, 36, etc. Well, the biggest perfect square that goes into 32 evenly is 16. So I'm going to split this up as root 16 and root 2, because 16 times 2 is 32. Well, the square root of 16 is 4. So I'm going to reduce that to 4. And you can't do anything with the root 2, so you just leave it as is. So your final answer is 4 root 2. And sorry, I know that's a little squished. I didn't have a lot of room. So I'm actually, for that reason, going to zoom in here on number 2 so I can write a little better for you guys. Okay, so for RS, let's write down our coordinate points. R is -3, -2, and S is 1, 1. I like to again label my y1, y2 and stuff. So for R, I'm going to make that x1 and y1, and I'm going to make S, x2 and y2. And now I'm going to plug everything in. So I'm finding the measure of RS equals, put your big square root sign. The first thing is subtract your x's. So that's going to be -3 minus 1 in parentheses and square it. Plus, then subtract your y's. -2 minus 1, put it in parentheses and square it. Now simplify inside of your inside of your parentheses. -3 minus 1 is -4 squared. -1 minus 1 is -3 squared. So you should now have -4 squared plus -3 squared. Now the reason the parentheses are still going to be important here is because when you square a negative, you need to have the parentheses or else it doesn't, it stays negative. Your signs get all messed up. So -4 squared is 16. -3 squared is 9. 16 plus 9 is 25. So you should have the square root of 25, which is a perfect square. And your final answer is 5. So if you end up with something that's a perfect square, you should reduce it. If you get a radical that can be reduced, again, reduce it. If you get something that can't be reduced, just leave it as a radical. You don't need to change it into a decimal. I actually don't want you to change it into a decimal. So if you get like the square root of 11, you can't do anything with that, just leave it. So the next things, or the last couple things we're going to talk about has to do with midpoints. I went down too far. There we go. Find the midpoint of segment RT. So I know I'm really zoomed in, but look at your paper. Here R is -3, -2, and T is 5, -3. So I'm going to use my midpoint formula this time, but I still need to know my x1s and my y1s and such. So for R, -3 is going to be x1, and then -2 is y1, and then I'm going to make point T x2 and y2. And now I need to plug it into my midpoint formula, so I'm just going to put m equals. And then for this formula, you add your x's and divide by 2. So that's, we'll put a big set of parentheses. -3 plus 5 divided by 2, comma, then add your y's, -2. And here it's up to you. You can either put plus a -3, or if you're adding a negative, you're technically just subtracting. So you could also just write -2 minus 3 divided by 2. Then simplify. -3 plus 5 is 2. So you have 2 divided by 2. -2 minus 3 is -5 divided by 2. And then reduce if you can. 2 divided by 2 is 1. And -5 over 2, you could either just leave it as -5 over 2 if you want. You could turn it into -2.5. You could write it as -2.5. Completely up to you how you want to do that. Okay. And then for number 4, it says the midpoint of segment JK is M, which is 2, 1. And one endpoint is J, which is 1, 4. Find the coordinates of endpoint K. Now you have to read this carefully. A lot of people will just take these 2 points and plug it into the midpoint formula because they see the word midpoint. Read your problem carefully. It already gives you the midpoint. Midpoint is M, which is 2, 1. Doesn't want the midpoint. It wants your other endpoint. Now there is a fancy algebraic way to do this with your formula. If you'd like to look that up, you're more than welcome to. But I have a strategy that doesn't require us to plug anything into any equation, and it's more of like a visual counting method. So what we're going to do to visualize what we have is we're going to draw a vertical segment. Now we're dealing with segment JK, so label your endpoints J and K, and you have midpoint M. Now you were told that J is 1, 4, so I'm going to write that down, 1, 4. And you were told that M is 2, 1. We don't know K. K is missing. We don't know it. We need to figure it out. Well, we know M has to be right smack dab in the middle. So what we're going to do is we're going to actually kind of count this out. If M has to be in the middle, think of what number, look at just your X value for now. If you have 1 and 2, what number would make 2 in the middle, right? So how I kind of like to do this is just think adding and subtracting. Look at just your X's first. To get from 2 to 1, you have to go up 1 unit, which means to make 2 be in the middle, you have to go up 1 unit again, which would make that 3. Then for your Y's, from 4 to 1, you had to go down 3 units. So to make 1 in the middle, you have to go down 3 units again. And 1 minus 3 is -2. So that means K, your other endpoint, is the coordinate 3, -2. And you can always check it by plugging them back into the midpoint formula if you want. Plug your 2 endpoints in, make sure 2, 1 is still the midpoint. But this is just a strategy for doing it. Again, if you'd rather do it algebraically, you can look up a strategy online. There are some different ways to do this. So last one, let's try this one more time to make sure we understand. It says the midpoint of segment AC is B, which is 2, 4, and one endpoint is A, which is negative 1, 9. Find the coordinates of endpoint C. So in this one, again, you're given your midpoint. You want to find the other endpoint. So let's give ourselves our picture. We need our visual. We have segment AC with midpoint B. It tells you that midpoint B is 2, 4, endpoint A is negative 1, 9, and C is missing. We have to find it. So again, we need to figure out numbers that would make 2, 4 be right smack dab in the middle. So let's figure out our differences here. To get from negative 1 to 2, you would have to add 3. Well, 2 plus 3 is 5. And to get from 9 to 4, you would have to go down 5. So go down 5 again, and 4 minus 5 is negative 1. And that's it. Sorry about the announcement. So C is 5, negative 1. Okay, and you guys can check that as well. Let me know if you guys have any questions. Get this done before your next class, which is either Tuesday or Wednesday, depending if you're maroon or gold day. And don't forget, Monday is an 8-block day. We're just going to be doing an activity that day. All right, have a nice day.